Namaste one and all. Today let's we understand the concept called multi-stage amplifier. This multi-stage amplifier will come under VTU Electrical and Electronics Department third semester subject that is called Analog Electronic Circuits BEE 303. Here now let's we understand about multi-stage amplifier. In the multi-stage amplifier, we are going to use majorly two types. The first one is cascade connections. Second one is cascode connections. Now let's we concentrate on cascade connections. What do you mean by cascade connections? What do you mean by multi-stage? Here in the amplifier, we have different stages. For example, if you are use one stage that is nothing but a single stage amplifier, here we are going to use multi-stage, one and other, okay, one more amplifier. So here we are going to use more number of amplifier stages. So that's why it is called multi-stage amplifier. Now, what do you mean by this cascade connection? Whenever if in case, for example, we are going to use two stage, for example, you can consider two stages. Both stages are common emitter configuration. Then it is called as cascade connections. If in case one stage is common emitter, another stage is common base, that is the case, then it is called as cascode connections. Okay. Now concentrate on only cascade connections. What do you mean by cascade connections? Before that, let's we understand what do you mean by this multi-stage amplifier with small example and small derivation. Okay. When the amplifications from the single stage amplifier is not sufficient for a particular purpose, when the input or output impedance is not sufficient or suitable magnitude for the intended applications, two or more amplifier stages may be connected in cascade. It means whenever single stage amplifier is not able to provide enough voltage gain or input impedance or output impedance, in that time we go for another stage. Okay. Now, what do you mean by this one is the output of the single stage, first stage, the output of the given stage is connected to the input of the next stage. Such arrangement is called cascade connection or multi-stage amplifier. Means here the first stage output is connected to the next stage input. So here you can observe this first stage output we are going to connect to the next stage input. That is called multi-stage or cascade amplifier. Okay, please take down this diagram. Here, this is the first stage, this one is second stage, this one is third stage. Okay, I'm going to consider three stages here. I'm going to give the notations like VI plus minus VI input voltage, and AV1 is nothing but voltage gain 1, voltage gain 2, voltage gain 3. Okay, and VI is nothing but input voltage, and then ZI1 is the input impedance of the first stage amplifier, and Zi1 and is equal to Zi2 is both are same. Zi and Zi1 is both are same. And Z01 is the output impedance of the stage 1. And V01 is the output voltage of the stage 1 amplifier. And V02 is the input voltage of the next stage, second stage amplifier. Here you can observe V01 output of the first stage is equal to input of the second stage. Okay, and then Zi2 is the input impedance of the first stage, Z02 is the output impedance of the second stage, and here Zi3 is the input impedance of the third stage. Here V02 is the output impedance of the second stage. It's nothing but input impedance of the input voltage of the third stage. And what is the third stage output? V03 or V0, both are same. V0 or V03, both are same. Here also output impedance Z03 is equal to Z0, both are same. Okay, I hope all of you understand this uh, block diagram or constructional diagram. What do you mean by this? AV is nothing but voltage gain. Voltage gain is nothing but a efficiency, like efficiency, not particularly efficiency, it's like a efficiency. What do you mean by voltage gain? A ratio of output to input voltages. Output voltages divided by input voltages. So please, we know that Zi1 is nothing but Zi. Okay, Zi3 is nothing but Z0. Sorry, Zi3 is nothing. Sorry, please note down this. Now this one is Z03 is equal to Z0. Not Zi3 is equal to Z0. Z03 is equal to Z0. V01 is equal to Vi2. Why? Because here observe V01 is equal to Vi2. V02 is equal to Vi3. Please change, make these changes. Z03 is equal to Z0. Okay. And the overall voltage gain of the cascaded system. Here, how much stages we have? stage 1, stage 2, stage 3. Overall voltage gain of these three stages is nothing but AVT is equal to V naught divided by VI3, V naught divided by V naught 3. The third stage output divided by third stage input into V naught 2 divided by V naught VI2 into V naught 1 divided by VI. Okay, overall voltage gain is nothing but AVT is equal to AV3 into AV2 into AV1. Okay, another manner how we can represent AVT is equal to we can make the changes reverse order in reverse order. AV1 into AV2 into AV3 all are same. What do you mean by this AV3? AV3 is nothing but voltage gain of the third stage V naught divided by VI3. I wrote same like this, but it is called loaded voltage gain of stage 3. Second one is AV2 is equal to AV naught A naught V naught 2 divided by VI3, VI2 is equal to, that is nothing but loaded voltage gain of stage 2. And then AV1 is equal to V01 divided by output voltage of stage 1 divided by input voltage of stage 1 is nothing but loaded voltage gain of stage 1. Okay, overall it is nothing but a gain output divided by input. If in case third stage, loaded voltage gain of third stage, loaded voltage gain of second stage 2, loaded voltage gain of stage 1. Okay, you can reduce this equation like AVT is equal to, we know output voltage divided by input voltage is equal to, all of you observe here, we know V01 is equal to VI2, V02 is equal to VI3. Please write down this equation like this same equation, everything is remaining same, but observe here, V01 is equal to VI2. Please write down here, V01 is equal to VI2. And then another case, V02 is equal to VI3. Please write down here V02 is equal to VI3. Okay, all of you should write you should make these two changes. V02 is equal to VI3, V02 is equal to VI3, and V01 is equal to VI2, and cancel this one. VI3 will going to cancel. VI2 will going to get cancelled. What is the remaining equation? AVT is equal to V0 divided by VI. V0 divided by VI. Okay, what is the output? What is the overall voltage gain equation? Output voltage divided by input voltage. If in case any number of stages are there, the equation will going to remain same. Okay. Okay. This question may be come in the examination. Please note down. Very important question. And for this three stages amplifier, we need to find out the current gain, total current gain. We already find out the voltage gain, total voltage gain. We need to find out the current gain. How to find out the current gain? Gain is nothing but a beta, gain, HFE, all are same. Okay. Gain, yeah, AI is equal to I naught divided by II is equal to, what do you mean by I naught? I naught is nothing but a output current. Output current is nothing but a, apply Ohm's law. Output current is equal to output voltage divided by RL. Here I'm going to use I naught because I naught is, I naught is nothing but output current. In the common emitter configuration, I naught is nothing but a minus IC. Here I'm going to change that one is I naught is nothing but a Ohm's law apply madi. I naught is equal to V naught divided by RL, obviously. But here we need to mention minus because minus I naught this one. So that's why I'm applying minus V naught divided by RL. And I is, I out apply Ohm's law, VI divided by ZI. ZI you can mention or RI you can note down. Everything is remaining same. Okay. Next apply minus V naught divided by RL. You wrote as usual. And then please take the denominator to numerator. It will going to changes like ZI divided by VI. Please mark this one. Minus V naught divided by VI. You know what do you mean by this one? Voltage gain. A minus AV like this. Minus AV into ZI divided by RL. The final equation is AI is equal to minus AV into ZI RL. Okay. Final equation, Now, please apply for this n number of stages. Okay. Everything is remaining same, but you need to change AV3. It is not AV3, AVN. VIN, V0 N. Okay, everything is remaining same equation. Okay, AVT is equal to AV1 into AV2 up to AVN. N number of stages you can make this according to your particular application. Okay. Now, please take down this example. This example also very easy example, but sometimes they will going to ask this question in the examination for 8 or 4 or 6 marks. Okay, please note on very simple explanation. So, very simple example. Let's see solve this example. A given amplifier arrangements at the following voltage gains. Okay, they will going to mention three gains. Okay, AV1 is equal to 10, AV2 is equal to 20, AV3 is equal to 40. What is the overall voltage gain? We need to find out AVT is equal to AV1 into AV2 into AV3. Now, and also express these gain in dB in terms of decibel they will going to ask, and Determine the total voltage gain in dB. Okay, for 8 marks they will going to ask you sometime this question. Overall voltage gain, you know the formula. AVT is equal to, you can see, AVT is equal to AV1 into AV2 into AV3. Please solve this problem. AV1 is equal to AV. Please substitute the values. AVT is equal to AV1 10 into 20 into 40 is equal to 8,000. In terms of dB, how to calculate in terms of dB? We know the formula. 20 log AV, 20 log voltage gain. What is the first voltage gain? 10. AV1 in terms of dB is equal to 20 log, substitute 10 is equal to 20. You're going to get 20 in the calculator. Okay. Now, and then second one, AV2 in terms of dB is equal to 20 log 20. Second one, AV2 is equal to 20. That is nothing but 20 log 20 is nothing but 26. Like that, you need to calculate third one. 20 log 40 is equal to 32. So overall voltage gain here, you need not to use multiplication, you need to use summation, or like add, you need to use additions. Okay, addition plus. Okay, AV1 plus AV2 plus AV3 in terms of dB is nothing but 20 plus 26 plus 32, that is nothing but 78 dB. This is the overall explanation about the multi-stage amplifier and three stages amplifier, and some with the help of one simple problem. Okay, now let's learn about Darlington emitter follower connections, or Darlington connection, in the next video. Okay, thank you. Thank you so much. Actually, it is come under in the third video. Okay, thank you.